So for today, we are going to jump into the correlational method. And we finished out last class, we talked about observation and observational method and the limitations with that and how it's great for some things, but unfortunately, it can only describe behavior. It can't give us any information on relationships, how things are related, or why they're related. It doesn't give us information on causal. So like we can't say like it's not causality. So we can't say like A causes B. It's just a description. So correlational method is a way for us to look at doing a methodology that's sort of a step up from observation. And sometimes it just makes sense for the question that we're asking. And so what correlational method allows us to do is look at two variables to see if they're systematically related. So we measure two variables and then we compare them across each other, and we can do this multiple times to have multiple correlations. And really what we want to see is, can we predict one behavior or one variable from another? And so we use a statistic called a correlation coefficient, sometimes called the Pearson's correlation coefficient, depending on which statistic you're using. And this is represented as a lowercase italicized r. And this particular number tells us a lot about the relationship. So it tells us how strongly two things are related, and it tells us what direction that they're related. So as one increases, does the other one increase? As the other one increases, the other one decrease? That would be an example of a negative relationship. So if one increases and the other decreases, okay, that will give us a negative relationship. If one increases and the other increases together, then that gives us a positive relationship. So it tells us direction and it tells us strength. So looking at the number itself can tell us exactly how these two things are related. One example question that we can ask with correlation would be something like, what is the relationship between the amount of violent television that a child watches, and then how aggressive are their behaviors? And so we can actually look at the relationship between these two things. So we would measure maybe the number of hours that a child watches violent television, and then we would look at how many aggressive behaviors that child exhibits over a period of time. And then we put these numbers in the formula, and then it spits out an R value, and it tells us how strongly those two are related and what direction. So we could have different directions, right? We could say, as children watch more violent TV, they become more aggressive. Or we could say, as children watch more violent TV, they become less aggressive. And we can say that there's no relationship. It doesn't matter how much TV a person watches. It doesn't predict their violent aggressive behaviors. And honestly, you could look at this different ways. You could say, well, how many aggressive behaviors versus how many hours of TV they're watching. But we usually start with a particular beginning and then look at prediction based off of that. So if we expect that it's the television that's influencing aggressive behavior, we'll start the sentence that way. So when we look at the sign that's in front of the R, okay, so a positive or negative, that tells us what we call direction. So a positive correlation, so if it's a positive R value, then that tells us if it's a positive correlation. As one value increases, it is associated with an increase in the value of the other variable. Okay, so an example of this is that so we know that height and weight are positively correlated. Okay. And so if we look at this R right here, notice that there's no sign in front of it. So we assume it's a positive. Okay. So we could put a plus there, but generally, if there's no plus, we assume that it is a positive. And the positive part of this R tells us that it is a positive correlation and the direction is in a positive way. So as the taller you are, okay, the more you weigh. And think about it, if that was reversed and the taller you are, the less you weigh, then NBA stars who are like, 6'7", 7 foot would be just sticks. right? And then like little kids would be like penguins because they would be, the shorter they are, the more that they weigh. That would look really funny, right? So we know that a positive correlation is, in this case, the taller you are, the more likely you are to weigh. And that is an R of about 0.47. And we'll talk about the value of R in a minute, but right now we're just talking about direction. If we were to look at this in our example of violent television watching and aggression, a positive correlation would look like, as children watch more violent TV, that's associated with an increase in aggressive behaviors. Okay. Now, looking at a different direction, negative correlation would be as a value increases, the other value decreases. Okay. And so an example of this is vaccination rates. So if we look at the vaccination rate of polio, for example, as the number of vaccinations increase, the number of cases of polio decreases, right? Because it's a negative correlation. So the more vaccinations you administer, the less of that disease. Okay, and that's the idea behind a negative correlation. If we were to use our example of aggressive or violent TV watching, as a child watches more violent TV, they act less aggressively. And so that would be an example of a negative correlation. Okay, so does anybody have any questions about the sign that goes before the value? So let's say that this particular vaccination rate correlation was 0.47. This would go R equals negative 0.47. So this would show us a negative value because it's a negative correlation. The correlation coefficient, the R, can range in value from a -1 to a 0 to a +1. It never goes above a 1. If you have done your statistics and you get a correlation coefficient of -2, you did something wrong. If you got a correlation of +4.0, you did something very wrong, and you need to go back and check your work, because we're only looking at values that range between -1, 0, +1. And so your direction, remember, is marked by the positive or the negative. An absolutely perfect positive correlation would be a +1. And that's an absolutely perfect positive relationship. An absolutely perfect negative relationship would be a -1.00. So perfect positive would be +1.00. Perfect negative would be -1.00. And a 0 correlation means 0 relationship. -1 and +1 are extremely rare in the real world. You're not going to get this because it rarely exists. It is, the closest that you might get is like a +0.98 or -0.98. That might be close to positive. And don't think of the values as, don't think that. So let me ask you this. Which one is a stronger relationship? A -0.98 or a +0.98? So which one is stronger, a -0.98 or a +0.98? What do you guys think? So if positive, negative means direction, and the number represents strength, and the closer you are to 0 represents, the further you are from 0, the closer you are to 1 represents strength. So I'm seeing a lot of answers here. Let's think about this. I got one. I got one who said it. If you have a positive 0.98 or a negative 0.98, they both are the same distance to +1 or -1. Did you guys see that? So a 0.98, regardless of the sign in front of it, is closer to 1. And that indicates strength. So the number being closer to -1 or closer to +1, the further away as 0 it is, the the stronger that relationship is. So if we have a positive 0.98 and a negative 0.98, they indicate the same strength. Don't think of positive as a good thing and negative as a bad thing. It just indicates direction. It just indicates how those two things are related in terms of increase or decrease, increasing together, decreasing together. Okay. If they decrease together, okay, again, that's still a direction. It's not indicating that it's any less stronger than the other one. We have to look at the number itself. So the sign indicates direction, nothing to do with strength. The number itself indicates strength. So if I were to say which one is a stronger correlation, a negative 0.5 or a positive 0.5, which one would be stronger? The same. Exactly. It's the same. I'm not trying to trick you. I just want to make sure everybody understands. They'd be equal. Exactly. They're equal distance from zero. They're equal distance from, in this case, positive one and negative one. And so that would be a moderate relationship. And so we kind of rank them. So like, a 0.3 might be a very not super strong, but there's something there potentially. And then a 0.5 might be moderate. Then as you start getting into like 0.7, now we're talking about a really strong relationship. Again, irregardless of the direction, right? It doesn't, regardless of the direction, doesn't matter. We're talking about just sheer strength. Okay. All right. So I'm going to give you guys a couple of examples here. So here would be a positive relationship, positive correlation, as the amount, as the number of television watched increases, that were violent television increases, the number of aggressive behaviors increases. And so here you have what we call the line of best fit. So these are all, each one of these is a separate data point. And then we calculate a line of best fit to give us an indication of direction. Here we have a negative example where the amount of violent TV viewing was low, and then there was a high number of television watching. Are the actual data points here. This is aggression here, and then this is television watched. So a high amount of television watched with a low amount of aggression. And then here would indicate a line of best fit that fits in with a negative correlation. Now, as you can imagine, this is not indicative of a normal data set, right? We don't typically see that as children watch more violent TV, they are less aggressive. This would be a fake correlation. Here is an example of no correlation. So amount of aggressive behaviors, amount of television watched, just the data points are everywhere. And if we were to do a line of best fit, what do you think that line would look like? So if I actually calculate a line of best fit, what would that look like on that graph? A line. That's exactly right. It would just be a total horizontal line, just indicating zero. It would just go just like that, boop, right across. So if you're trying to run a correlation and you expect to see a result, and you see that horizontal line of death, then you know that you have no correlation, and that looks bad. And that might be a correlation of 0.1 or 0.05, and that's just indicating no relationship there. Let's look at this one, for example. I think this is probably the easiest one to read. So every single data point matches with one person's viewing and that same person's aggressive score. So here, let's pick this one. We would say that their amount of television that they watched is slightly on the lower side, and they have 4 aggressive acts. Okay. Here would be an example of somebody watching a very high amount of violent television, and then here doing 6 aggressive acts. Okay. And so they fit really nicely on this line, because as the children who are observed, as we were to write down how much violent television that they watch and then measure that along with their aggressive acts, here you can see that this child right here doesn't watch any violent television at all and doesn't engage in any aggressive acts. This child right here watches a very large amount of violent television and also engages in the highest amount of aggressive acts. And then each data point is going to represent. Now you're going to notice that we got a couple outliers here, right? And that's going to pull the data. And if you have a reason to pull those outliers out, like let's say there was something wrong with this case where it was an exceptional circumstance for whatever reason, you can pull that data point out. And then what you'll notice is that it'll fit even closer to your line of best fit. If you don't have any reason to pull these outliers out because it's just how the data go, then you just got to let it move. For example, here, there is a person who engages in the most aggressive acts and watches no TV, no violent TV. Here, this would be a very counterintuitive data set that you would not expect to happen. Here, the kid that is engaging in the lowest amount of aggressive acts, but also watching the highest amount of violent TV. You see how that's like completely opposite of what you would expect? This is an example of a negative correlation. As the children watch more aggressive, violent TV, they engage in less aggressive acts, which doesn't make sense for what we know about violent TV. Okay, so when we are measuring different things, we use, for example, surveys to indicate what behaviors people do and what relationships we can gather from that. And so what we always want to try to do is gain what we call a representative sample. So a representative sample is a sample of people who reflect the group of people that you're trying to survey. So if I were to try to survey all college students across the United States, because I wanted to get a representative sample of college students, then I would need to try to randomly select college students of lots of different backgrounds and kinds. So I wouldn't just go to like Harvard and Yale because that's not representative of all college students, but we wouldn't want to ignore them because they do represent part of college students. So same thing when you're looking at different groups of people. So let's say you wanted to survey an entire city. Well, you would want to make sure that you get reflective of the number of men and women, or, if you're looking specifically at, different genders, if you're looking at different ethnicities, you would want all of that to reflect what the population is made up of. And so we typically use surveys to ask people about their behaviors, and then we can compute these correlations based off their answers. So if somebody says, well, if we were interested in how many products a person buys, and then if they use them, we can ask them, well, of this list, select all the ones, select the one that you purchase. And so we can, examine the frequency of that particular selection. And then we can look at if they actually use it. They can rate on a scale how often they use it. And we can look at these different variables in different ways. And then be able to get some really good information. But not only does it have to, our whole sample have to be representative, but we have to also rely on people being honest and telling us, what they think and how they act. Another example would be like political scientists wanting to know if a person's attitude predicts their voting behavior. So, like, for example, they can question people about how they feel about gun control, and then they can see if that predicts how a person will vote in the next election. And then that informs them, oh, okay, catering to this particular audience, if we want to have more votes in this area. So that kind of informs other people how to use that information. But a way to make a representative sample is to randomly select people. So everybody has an equal chance of being a part of the survey. You're always going to have a little bit of bias there because people who choose to do surveys are always going to be slightly different than people who decide not to do surveys. There could be definitely bias there because it's a sort of a selection bias where people who don't ever do surveys don't get represented in the sample. So there's always going to be some issues with surveys, but we just try our best to kind of get around that. Now, looking at some of the advantages to surveying people and then being able to generate these correlations, the good thing about surveys is that we can look at behaviors that are normally very difficult to look at without simply just asking people. So we can't really observe people in the bedroom and their sex habits. So we ask them, how often do you have sex? How many partners do you have? And we can ask them how much they know about different diseases, like, for example, AIDS, HIV, things like that. And then we can try to do pieces of population. So, for example, let's say we were interested in um, uh, uh, sexual orientation, and we wanted to see how people engage in certain sexual behaviors, how many partners they have, and their knowledge of HIV. Looking at heterosexual couples, homosexual couples, bisexual couples, we can look at a lot of different things, and by taking segments of the population and trying to represent those individuals. Um, so the problem though with surveys is that one, not everybody's honest, especially when asked about very specific things like how often they engage in safe sex, and people will end up responding based off of how they think they should respond and what's socially acceptable because they don't want to be judged. One thing that we're going to talk a lot about in this class is about your image of yourself and how you want to be good, and you want to be right, and you want to have people look at you in a positive light. And if you are engaging in really unsafe behaviors and you're doing a lot of risk taking and you know that it's bad, you might not report that because you don't want to be judged. You don't want anybody to come and say, um, oh, that's yucky, don't do that behavior, sort of thing. And so it's just important that we try to word questions very sort of non-judgmental, very kind of factual, to try to avoid some of that. Another issue is that sometimes people don't know the answer, but they think they know, and they're wrong. Or we try to predict how we're going to behave, but sometimes it always doesn't actually happen the way that we think it would. And so it's hard to get around that, but these are definitely disadvantages. Um, Another thing that we have to consider is that there are certain limitations to correlation, and that is that it does not give us any information about causation. We cannot say that, watching violent behavior, watching violent TV causes children to act aggressively. It's just impossible. We cannot derive that relationship with a correlation. Correlational methods only tell us that they're related, the direction of relation, and how strongly they're correlated or related. And that is not something that we can really do with correlation. We can't go beyond that. We can't go beyond the direction and the strength of relationship. And so, because in social psychology, the goal is to identify causes of behavior. We can't rely solely on correlations to answer those questions because it doesn't answer the question. In order to say that, variable A causes variable B, not just that they're related, that would mean that we would have to do an experimental methodology. So we would have to actually design a study where we manipulate some variable in order for us to be able to control enough of the situation to then say, okay, um, this is, uh, um, all things considered, to the best of our ability, likely we manipulated this variable, so it's causing this behavior. And that is probably the best thing that we can do in this particular case.